Okay, hello, welcome to my channel. Now in this video, we're going to find the sum of the reciprocal of the double factorials of even numbers. Alright, so you notice what the double factorial of a number tells us. It tells us that we are going to be descending, or the product will be descending by 2. So if you have 2n double factorial, okay, we can rewrite this as 2n times 2n minus 2. Okay, and we multiply it by 2n minus 4, and we can continue and so on, infinitely many of them depending on how many n is, but we will be ending with numbers as 4 and 2. Okay, for the odd terms, that is for the double factorial of odd numbers, we are going to end with 3 and 1 because those are just odd numbers. Okay, so taking note of that, that means we can rewrite this sum as the sum as n starts from 0 up to infinity of 1 over. This thing can be written as using that. That will be 2n times 2n minus 2. Okay, we can continue as much as we want till we get to 4 times 2. Okay, that's nice, isn't it? So you notice this. From there, we can notice that we can factor out a 2 from the denominator. That is, factor out 2 from each of those terms. 2 from here, 2 from here, 2 from here, 2 from here, and so on and so forth. Alright? So when we factor out a 2, given that we have this, that would be like taking out a 2 from this first term. When we take out 2, we will just have n left there. Alright? N will just be left. Take out 2 from this second term here, we'll be having 2 out. Okay, we'll be left with n minus 1 there. Alright, this is not 2 to the power n, you just factor out the 2 and you have n left. And all these are multiplied together, so you notice this term will be 2n minus 4. So if we factor out a 2, we are going to have n minus 2 left. The next one will be 2n minus 6. So if you factor out a 2, you'll be having n minus 3 left, and so on and so forth till we get to this point. If you factor 2 from 4, you're going to have 2 left. And if you factor 2 from itself, you will have just 1 left. So what that means is factoring 2 from each of those terms in the denominator and multiplying all of them together, we are going to have n of them. So we're going to have 2 n's. That is, n factors of 2. That will be 2 to the power n. So we can rewrite this as the sum as n starts from 0 up to infinity of 1 divided by this. Factoring out a 2, as I said, we're going to have 2 to the power n left. And then the remaining will be n times n minus 1 times n minus 2, and so on and so forth, which tells us that we're going to have just n factorial at the bottom. Okay, that's nice, isn't it? So let's see what we have. So from here, we can rewrite this a little bit so that we have a sum as n starts from 0 up to infinity of, well, let me rewrite this fraction, and by bringing the 2 to the power n up there, we're going to have 1 over 2. We raise that to the power n, and then we divide this by n factorial. So I want to remind you that if we have a number e to some power t, this can be rewritten as a sum. Let's use k starting from 0 up to infinity of t to the power k divided by k factorial. So a situation where this t becomes just 1/2, it will be of this form. So in fact, this right here is just e to the power 1/2, which I can rewrite it as the square root of e. So this is very nice, isn't it? Okay, great. Right. Thanks for watching, and please subscribe to my channel and share this video with your friends. All right. I'll see you in our next video.